Hello everyone, and welcome to another TrailCam data tutorial. Today we'll be working with deer activity data and designing forecasts to make the most out of your next outing. Throughout this tutorial, we'll be working with Excel's Analysis Tool Pack. So before we get started, let's go ahead and download the tool pack. Now the way we're going to do that was we're going to go up to File, down to Options, and that'll open up this text box here. We'll go down to Add-ins, and then down at the bottom there's this little text here that says manage and then a button that says go. So let's go ahead and press that. And then I'm prompted with a list of different items, and at the very top we have Analysis Tool Pack. Now when I do press OK, I already have Analysis Tool Pack installed, so that should automatically be added to my ribbon up in my data tab over here. If you don't have it yet, Excel might ask you to install the tool pack. So just go ahead and press OK and go through the whole process. If you don't have Analysis Tool Pack installed at all, you may want to click Browse, and if nothing shows up, I do recommend going to Microsoft Excel's website, and they may be able to help you troubleshoot the whole Analysis Tool Pack installation procedure. So let's go ahead and press OK. All right, so you might notice that up here in the ribbon, there was one change over here, which was this little analysis over here, and I have now gained this ability to conduct data analysis. So that means we're ready to go and get started with our tutorial for today. Now, if you are using a different program altogether, I suggest finding an add-in that has the word regression or ANOVA in it. Everything we're covering today is something we're working on at TrailCam Data, so you will have access to these analytics shortly, but for us, it's really important that you have complete control of all your data. And sometimes even just getting a rough understanding of where all these numbers are coming from can be really helpful. So we will be using the data we had from before in our video on deer activity. So I slightly modified it by adding some rows. I did this because we will be needing more rows. So that's this, then columns. That's these individual columns over here for our analysis. That's something that data analysis requires. All right, so in this tutorial, we're going to be working with a statistical method called regression. All regression really is we'll hopefully be able to put together a formula that uses weather forecasts to predict your deer activity. I personally think this is the coolest thing ever, and if you haven't spent time with regressions before, which frankly is not something we use very often, will turn you into a scientist of the outdoors. And I promise that at the end of this tutorial, you will find regressions not only easy to do, but they're actually going to be fun and can be applied to a lot of things in our day-to-day lives. Now, you may remember that in our previous tutorial on deer activity, we calculated correlation and R-squared. Let me go ahead and browse to that tab over here. So here we have our correlation and R-squared from day to day and minute by minute. Now, while these are really helpful, doing this regression analysis is actually something we should be doing before we calculate correlation or R-squared. And the reason for that is because let's say I have a high R-squared. So in this case, pressure, for example. Now, the problem is we may not really know whether pressure is directly impacting or affecting deer activity, or whether in this short time period here, over this period of 6 days, pressure and deer activity just so happen to move together. So correlation and R-squared are useful, but this regression will really help explain everything that's going on between these two variables. In fact, what we're going to do is we're going to hopefully explain how all of these variables, minimum temperature, maximum temperature, visibility, all of these weather-related pieces of information, how those impact deer activity. So I'm going to go ahead and browse back to my regression tab over here. So let's go ahead and go to this new tab here with all of our data. As you can see, we have all of our weather-related information over here, as well as our deer activity. So let's go ahead and get started. All right, so the first thing we're going to do is to scroll up to our data tab in the ribbon and click on data analysis. This is going to open a text box with a number of options over here, but the only thing we're going to be focusing on is this regression item. So I'm going to click on regression and then select OK. Great. So I now get a text box with a few different options. And the first thing that I have here is this input Y range. And my input Y range is going to be my deer activity. Essentially what I'm saying is I want the model to be able to predict everything within this Y range over here. So I'm going to select this up arrow and then select this entire column over here with the label deer activity and then select this down arrow. With that, we've effectively selected this deer activity column. The next thing I'm going to do is then go ahead and select my input X range. My input X range includes all the variables that I think will be able to predict this deer activity or my input Y range. So I'm going to go ahead and select the up arrow, select all of these variables, these weather-related variables from minimum temperature to pressure, select the down key, and now I have the entire range there. Now the next thing I'm going to do is go ahead and select this checkbox called labels. Basically what I'm telling the computer is I've also included the row labels so that when I get this regression output, I'll also be able to see exactly what those numbers are relating to. Next, I have this confidence level. Now, all confidence really is we're going to tell the computer how accurate we want to be with this model. Do we want to be 95% accurate or 90% accurate? Well, there are a few different things to think about. For example, how much data do we have? In this case, we have about 12 days worth of data. And within those 12 days, I had 62 images grabbed from cameras that were placed on a small piece of land. So to think about whether I have enough data to forecast all deer activity with all the deer in the nearby area may be a bit too aggressive within 100% confidence. And the higher we make this confidence level, the less likely we'll be able to build a model that really gives us value. So in this case, I don't really recommend going over 90% confidence level. So let me go ahead and type that in here. And what this tells me is I'm going to give myself a 10% chance of being wrong outside of this model. Now, if you want to get more technical, there are a number of tools online that will tell you how much data you'll need in order to get to your confidence level. Like, for example, SurveyMonkey has a calculating tool for this, but I think we'll be just fine with this 90% confidence level. Another way to say this is we have an alpha equal to 0.1, or that 10% outside of the 90%. And the reason why I'm saying that 0.1 is our alpha, because we'll be using that later on in our regression. So the next thing I'm going to do is I'm going to select where I want all of this data to be outputted. There's going to be a number of variables that we're going to get from this. So we can either place this into a brand new tab, or we can place it right here on this sheet. I prefer placing all of my data on the same page. This way I really get to see what's going on and I can play around with the data a little bit more easily. So I'm going to do just that. I'm going to select this output range radio button and then select this up arrow. And all I really need to do here is just select one cell. And in this case, I'm going to select Q. And you may see that my Q column here is wider than all my other columns. And that's because I ran this whole process before. And you'll see that we're going to need a little bit more space here to fit all of our labels. We could place this into our P column or O column, but I always like to give myself a little bit of space when I'm running new sets of either equations, formulas, or graphs. I like to separate out my data from all the other things that are going on. So I'm selecting Q1 over here. Then I select this down button again. And then I leave all these other checkboxes unchecked. And I'm going to press OK. All right. So that about does it. So now we have an entire output of our regression model over here. And there's quite a few things going on here. So I'm going to briefly describe what's happening. Essentially what we have here is we have our regression statistics. These tell us how good our model is. Then we have this ANOVA here. That's not really important. All this helped us understand was whether this model is going to be useful at all. And then it gives us this entire output with coefficients, standard errors, t-stats, and a wide variety of columns and data points here. Frankly, the good thing is we don't have to pay attention to most of this. In fact, for the first few steps of this exercise, all we're going to be focusing on is this p-value over here. So what I'm actually going to go ahead and do is I'm going to highlight all the areas that you really don't need to focus on, so that way we can really start narrowing down our field of view so we can get really specific about what we're trying to do here. So I'm going to go ahead and highlight this lower 95% all the way to my upper 90% in red, as well as my standard error, my t-stat. I don't need any of that. I don't need this ANOVA stuff here either. In fact, I can even say I don't need my adjusted R-square or my multiple R. My multiple R is my correlation that we had calculated beforehand. And my adjusted R-square is something that I'll explain a little bit later, but it's really not going to be important in the long run here. So we now have our p-value, and then we have our coefficients, and I'll explain what those are a little bit later. But this is what we have, and this makes our process a lot easier. All right, so you may recall that I had mentioned this term called alpha equals 0.1. In other words, we said we want our model to be within a 90% confidence level, or we're giving ourselves a 10% error rate here, or 0.1. And so what we want to see here is we want our p-value to be less than 0.1 for any of these variables over here. And in this case, you'll notice that none of our variables here currently are below 0.1. What I also did was I purposefully included my average temperature and visibility numbers in here that would end up giving me this error here because it's very likely that you're also going to get an error as well. So what's the first thing we're going to do here? Well, I had mentioned that what we want, and the only way we're going to get a good model is if we get our p-values below 0.1. Well, in order to do that, we're going to start removing some of these variables. And you're going to start seeing that as we start removing variables, these p-values across the board will start dropping. So the first thing we're going to do is we're going to go ahead and get rid of these error values over here, average temperature and visibility. So I'm going to duplicate this table here from my date all the way to my pressure by doing Control-C. And then I'm going to go ahead and paste it down here at row, go ahead and put it at row 30. This way I can just keep all my data organized and keep it one row at a time. So I have all this information here, but as you may recall, I said that we need to remove our average temperature and visibility. So we're going to do just that. And the best way to do that is by selecting all of these other variables here, my wind speed all the way to my pressure, cutting it by doing Control-X, and then pasting it by doing Control-V over the average temperature. And that effectively removes average temperature as well as visibility. There's another way to do all of this. I could select an entire column and then right-click and then select Delete and then do Shift Cells Left. But in my experience, what I've seen is whenever I start doing that, it starts shifting around all the other columns, it starts moving numbers, and then I end up having to reorganize everything on my page. So I'd rather just paste everything over. And the great thing is since I'm duplicating all these numbers from up here, I can always revert back to these in case I may have incorrectly done a step along the way. So what's the next thing we're going to do? Well, we're going to run this entire process all over again. So in order to rerun the regression, all I'm going to do is go back up to the ribbon, go to the Data tab, and then select Data Analysis. I'm going to select the regression, select OK, and then this time around, I'm going to change some of these here. So my input Y range is going to be my new deer activity. All the numbers are going to stay the same as this is a duplicate. But this time around, my input X range will include all the weather variables except for average temperature and visibility, since those were eliminated. Everything else, though, labels and confidence level remains the same. And then my output range is going to be down parallel on row 30, so that this way I don't overwrite my previous regression output. And then I'm going to select OK. And that's all there is to it. So now we get a whole new set of regression outputs. And what you're going to notice is quite a few of these numbers have changed. For example, my R-square value here is now at 0.9398. And before this, it was 0.9695. Now, the reason why that happens is every time we add a new variable to a model, our R-square can only either stay the same
or go up. So even if that variable really doesn't have much of a significance, like average temperature or visibility, it will impact our R-squared value. And this is why I said it was so important that we did take this step, this regression step, before we start looking at our R-square or our correlation, which is our multiple R, so that we understand whether any of these variables are really having a direct impact on our deer activity. The next set of numbers that we're going to look at is our p-value. And you're going to notice that quite a few of these p-value numbers have changed as we've redone our whole regression analysis without the average temperature and visibility. For example, my pressure variable over here, when we ran it previously, we had a p-value of 0.34 or 0.35 rounded up. Our new pressure variable now has a p-value that is well within our significance range at 0.06. It's well within our significance range as in it's smaller than or less than 0.1, which was our alpha. So that's really great to see, and that's what we're going to start seeing is this trend of p-values starting to go down as we start rerunning these regressions, doing this stepwise regression model, or in other words, the method that we're doing here is called backward selection. That's not really important. What's important is to make sure that we're starting to see this p-value trend go downward. Now, we still see that quite a few p-values here are well above our 0.1 alpha range. So we still want to go back and start eliminating some of these variables one by one. And the way we're going to do that is we're going to look at the largest p-value. And out of all of these, I believe humidity has a p-value of 0.88. Then we have cloud coverage, which is 0.8. But 0.88 is larger. So what we're going to do is we're going to go ahead and eliminate humidity from all of these variables. And we're going to do this the same way that we did the average temperature and visibility as before. We're going to duplicate or copy this table over here that we had pasted into row 30. And then we're going to paste it over here. So Control C and then Control V down here on row 57, for example. I'm just placing it on any row. All that matters to me is to make sure that all of this is organized. All right, so now that I've duplicated this table, what I'm going to do is go ahead and eliminate this humidity column over here. In order to do that, I'm just going to go ahead and select all these values between precipitation and pressure, do Control X and Control V. Then I'm just going to go ahead and rerun this regression analysis by going to Data Analysis, select Regression, OK. I'm going to go ahead and select this new input Y range and select this new input X range, which includes all of the variables excluding my humidity, average temperature, and visibility. Everything else remains the same. My checkboxes for labels and confidence level are good. And then my output range is going to go ahead and go to 57 here. And then I'm going to select OK. All right, so let's go ahead and take a look. Now what we see here is quite a few of our numbers have changed once again. My p-value for pressure has dropped from 0.06 down to 0.02, which is really great to see. It means it's even better this time around. My precipitation intensity has also dropped now below my 0.1 alpha range. And this is exactly what we want to see. So this is what's happening. As we start doing this stepwise regression, we're going to start seeing these p-values fall within our significant value range.